So today we're going to talk about atomic theory. So how the model of the atom developed through time. First, some reminders. Make sure you pause and rewind anytime you need to. Make sure you write down all highlighted vocabulary words. There's quite a bit of it in this screencast. Be on the lookout for test question lists, whether I actually point them out in the screencast itself or I say them. And there's going to be no assignment for this to follow the screencast. The notes are very long, so just bring them to class and you'll get your 100. So the start of atomic theory started with a Greek philosopher named Democritus. And he proposed that matter was formed by small pieces that could not be cut into smaller parts. And he called it the atom, which is the smallest particle that can still be considered an element. And through time, his theory grew as more models were developed and experimental evidence was gathered. So our first major scientist for the atomic theory was John Dalton. He was an English chemist, and he thought that atoms were smooth, hard balls that could not be broken into smaller pieces. So with that, he came up with 4 basic rules. All elements consist of atoms that can't be divided. All elements have the same mass and are exactly alike. An atom of one element cannot be changed into another element, and then compounds form when atoms of more than one element combine in a specific ratio. We've been talking about elements and compounds for the past couple days now, so you should be pretty well on that. Our next scientist was Thomson, and he thought that atoms were made of many smaller parts. He discovered that atoms contain negatively charged particles called electrons. He also discovered that the charge of an atom was 0, so the negative charge had to be balanced by a positive charge. He didn't know where the positive charge was yet. Rutherford did find the positive charge, and he found that it was in the nucleus, which is the small region in the center of an atom. And his model was like a cherry, the pit of the cherry being the nucleus. So if you can picture a cherry in your head, he's got the small hard pit and then all that flesh that you eat around it. And he found that the nucleus had these positively charged particles, and he called them protons. And he also discovered the atomic number of an element, which is the amount of protons in an element. That's going to be very important when we start going through the periodic table. Then we had Nathan Bohr. Bohr suggested that the electrons are found in different orbits called shells. Orbits look like planets orbiting the sun. So you can see them here. This is actually a chromium element. And you can see the nucleus here with the chemical symbol Cr. We'll talk about that. And then all these little dots are the electrons. So these are all orbiting around the nucleus like a planet would, like the Earth does around the sun. Fast forward to the 1920s, and we have what's called the cloud model. And scientists determined that electrons do not orbit the nucleus. They just move rapidly within the cloud. So that's every time you've seen an atom before, that's what you see. So if you've ever seen one on TV, or you've ever seen it, when we watch Bill Nye, it shows up in the actual theme song. An electron movement is related to its energy level, and the energy level is the specific amount of energy an electron has. So if I go back to Bohr here, each one of these orbits is considered one of the energy levels. And electrons with different energy levels are found in different places, as I just showed you. Finally, what we have is the modern model. So James Chadwick discovered that there's another particle in the nucleus of the atom. It's called the neutron. It's a particle with no electric charge. Most of the atom is made up of the space where electrons move. So the nucleus is very small. The electron cloud is very big. And then he also found that the proton has a positive charge. The neutron has no charge. The electron has a negative charge. And he also discovered what are called isotopes, which are atoms with the same number of protons but different numbers of neutrons. And carbon is a major example of this. It has many, 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 many isotopes. So you have carbon-12, which has 12 neutrons. You have carbon-14, which has 14. And you have carbon-16, which has 16. And so on and so forth. And that's pretty much all I have.